Okay, my name is Matt Burnett. I'm an Azure advisor with DXC, and today's session is about migrating to Cosmos database. As we know or we don't know, right, Cosmos database is an Azure platform as a service function, and our outline today kind of looks like this. I walk through a number of the different parts of a database. Especially a NoSQL database. And I really want, in the very beginning, to give us a good fundamental and conceptual understanding of what NoSQL databases are, how they differ from relational databases, and then, of course, sticking really with the concept about migration, because that's really our core that we're talking about here, is how do I migrate databases, especially NoSQL databases? Or what if it's a relational database to a an object relational database? And then on the right here, you can see I've outlined about 13 different demos, just walking through Azure, doing migrations, understanding, pricing limitations, and RU units, which are cost functions. So let's get started. First, any questions? Now we see the outline. Everybody pretty clear? We're talking about Cosmos database migration, and we've got lots of demos. Okay, great. No questions then. So I brought this slide from my previous slide deck because it was the biggest big picture that I had, which was what is the Microsoft Azure understanding of databases. And then I quickly said, well, Cosmos database is not in here. How do I fit that in? So you could see I fit in a little Cosmos database in between the database services, different types of Azure database services. And you know what? It really starts to outline that there are many different types of database applications available within Azure, right? And really lots of different migration types. So within this case, I wanted to bring out what I call the slightly bigger picture, fit Azure Cosmos database into that as a NoSQL database type. And then I wanted to also point out at the bottom here that migration, just because we're using Azure and we're talking about Mongo databases or Cosmos databases, so types of NoSQL databases or relational database, who knows, all of them, right? Is that if you look in the bottom corner here, I've got other remote database management systems that we can just load on VMs. And in fact, the first few demos we'll go through are my Mongo databases loaded on Windows and Linux. And they're, of course, virtual machines running in Azure. They work perfectly well, and in many cases, they are the correct path for migration, is just maybe rehosting the database within an Azure VM. There's really no need to get really complex. So I always like to make sure that, before we go off talking about Cosmos and all the wonderful things we can do, we just know that, just running it on a VM is a perfectly valid path. The second thing is there are lots of different types of databases that can be migrated to Cosmos. So if your customer is asking for Cosmos database, we then have got a number of questions that we have to ask them about. So really, we have to start categorizing what the customer's database model is. A lot of times we'll know ahead of time because they'll say I have a Mongo database, or they'll say I have an SQL database, or MySQL database, or Oracle, and they want to migrate maybe, let's say Mongo to Cosmos. That would be the perfect type of migration because it's a linear migration. And so when I say a linear migration, that might not make sense, but let's make it make sense. And so when I say linear, what I'm talking about is that of the database types, right, we have relational, object-relational, and object-oriented databases. And a linear migration would be an object-relational model to an object-relational model. And so the best case scenario with very little transformation of the data required, if any, by the way, is Mongo database to Cosmos database. And in fact, it works very well and is very straightforward, and we'll demo it. However, what I really want to bring up here is the fact that if customers start asking us about, although I don't want to say nonlinear, what I make is different types of migration. So if they say something, I want to go Oracle to Mongo database, that's not exactly a linear migration, right? And it causes a lot of problems. It can be disruptive. When you're creating objects from relational tables, a lot of times they're transformed and the shapes are different. And so those are the types of questions we want to ask. And this slide really is so we can all say, okay, there are these differences, right? No SQL database types are object relational categorization for the most part, right? I understand I'm being a little broad. And that there's a distinct difference between relational databases and object databases. So, and moving on quickly to talk about this difference is that most applications that consume data for databases, right? They have purpose-built functionality, right? So we call them by exact names, right? They're an online transaction processing database. They're a document database. The databases have references, or they have other terms like consistency, scale, etc., to describe the database, right, and its purpose-built functionality for applications. And so these two buckets, when we have NoSQL and SQL as big buckets, we can look at the models and see why that purpose-built functionality is good or bad. To me, this is the primary reason we should talk to customers during or before a migration, is if they say something that seemingly is nonsensical, that they would say that I have a relational data model in SQL Server and I want to go to a document database hosted in document database, so a NoSQL database run by Cosmos database, we would really stand back and go, okay, well, let's ask a bunch of questions about this, because it's quite difficult to do that. Not impossible. And by the way, the tool I'll show you does it very straightforwardly. But there's a number of problems that occur within our application's data layer, right? Because it's just not built for that transition. And if customers are unaware of that, it can be exceptionally costly. So knowing all these things and kind of setting up that we have these different types of database that represent different models, right? And that models, the model that's implemented with an application is heavily dependent upon the application's data layer, which has queries to that underlying data model. And by the way, all of you should be just smiling and saying, yes, Matt, that all makes sense. So we also have an understanding of the types of APIs within that data layer of the application that do calls to the database. And so what I just said was SQL, right, is the type of query syntax used within a data layer and application to talk to a relational database, right? So we can walk forward and we would say, okay, I have different models. I have different ways my applications speak with the underlying data model, right? So that might be the query syntax. And then what we get is to what Azure Cosmos database multi-model is. Now, I have to say multi-model threw me the first time I heard it, because I'm like, what are you talking about, a multi-model? So multi-model means I have and support different models. If you look at my picture, the model I support can be a document database, a graph database, a key value pair database. And if you think about what those are, right, we know that DocumentDB by Microsoft is a document database. We know that MongoDB is a document database. We know that Azure Tables are key value, I guess you'd call it databases too. So these represent different models, and we can say, hey, Cosmos database supports these different types of NoSQL models. And that would be a correct statement, right? Because it does. There is also multi-API, And so when we talk about APIs, it's exactly what I said. So it's how does the application, right, query in the data layer, for example, the underlying data system. And so if it's SQL, then that might be the SQL API. If it's Mongo, that would be the Mongo API. If it's an Azure table, that would be the Azure Table API. And so Cosmos supports this, I guess I call it an underlying layer, which is the query support for the database type, right? So if it's relational, that might be an SQL API calling from a application that uses the SQL syntax. So that's why we call it multi-model. And this is one of the important points I wanted to talk about so that we all have an understanding of exactly what it is. It makes it more complex because it does all these things, but it's pretty straightforward. Now the rest of Cosmos Database is those things that I guess make it global in scale, highly elastic, and has a consistency model that we can set between atomic consistency, which is, I think, can be referred to type, which is, and then on the other end, the continuum eventually consistency. So let's quickly, if I click on this link, hopefully I haven't got anything I don't want you guys to see in my browser. We can see, first of all, that Cosmos Database talks about its APIs, which you should all understand now is how does the application talk to it. The reason why we have APIs is that if we have a migration, a database migration to Cosmos Database, we do not want to disrupt the application's data layer query syntax to the underlying data source. Thus, we have APIs. And that's the sheer purpose of it, is that if I do a Mongo database migration, and in fact, I want to go to Cosmos, I do not want to disrupt my application's data layer in communicating with its database. That's the first demo we'll go through. All right. So that at this point, you guys should say, okay, we understand that Cosmos Database supports many models, has APIs, has a lot to do with the application layer. We also understand that, yeah. So I have a question. For what data model? We support Mongo, Gremlin API, Cassandra, and Table API. That's right. If there are other APIs, right, you would have to migrate to that particular API model. And I'm going to set up the database right now so we can select it. So that, in fact, is the next demo. Let's get right there and get that fired up. And so, first of all, you can see I've got a number of databases running here. But what we're going to do is just go right there. It is. Right. And so when we create the Cosmos database, we actually have to attach the API type to it. And so Cosmos Database don't have multiple APIs that you can use. So what is necessary is that you have to know ahead of time which it is, and then it's going to be that, as far as I know, forever. Other than that, it's really straightforward to create. And so one of the things that we do during creation is we disable geo-redundancy and replication, and that's because it gets it's not cost effective. And the other thing is we want to set it to the minimum type of RUs. I'll cover that a little bit later. RUs are resource units, which determine the cost. So, when we're really testing it and figuring it out, and before we know the cost, this probably is a good configuration. All right, so while that's running, back to the demo. We'll come back there in a minute. And so one of the pieces why that was setting up is I really wanted to confer an understanding, and many of you understand this already, but one of the purposes and understanding of NoSQL databases is the storing of objects, is how we say it. And I wanted to really talk about our language here for a minute so that we understand that it's actually storing object graphs, right? And what I have in my pictures is exactly the images, so we can understand that very quickly, right? Is that what we have at the top is the person, and I like to call this maybe the concept of an object graph, because most of the time we see people talk about object graphs in this kind of canonical example. But in fact, the object graph, the person object graph, is the one below it where we see the instance values stored in the database. So what's actually stored in Cosmos database, right, is an object graph, which is the instance of an object, right? So it's persisted to store. And so what I did to help us understand this, and I like to be very specific in my terminology use, is the exact description from, of course, the wiki, so that we can see that, yes, when we talk about an object graph, it's an instance of an object stored into the database in many NoSQL systems. So although we see the canonical type, it's a direct-to-click graph, right? That makes us see what an object graph means. An object graph is actually the stored instance of the object graph in the database, as we see below. So what does that mean, right? Is that if we're working with objects in the database, then if we have a type of migration, right? Remember, a linear migration that goes object graph to object graph storage, Mongo database to Cosmos database, then we have a very linear and simple migration, because there would be no disruption to the object's graph definition, right, as stored in the database. And the easiest way to say that is the application's expected result from its query syntax would be the same as it transitions from Mongo database to Cosmos database using the Mongo API. Everybody should be nodding yes. That makes sense, Matt, because we're not changing the underlying storage of the object graph in the database. So when we talk about objects, object graphs, and shapes, right? Object is a class diagram definition, right? Object graphs refer to the instance of the class, right? And its children, if it has any, as we see in the kind of the abstract object graph to the right. And then a shape kind of refers to the object's defined or intended graph. That's kind of my own loose interpretation of it as well, because when we get to the data migration tool, it uses the word shape, right, to talk about how we transition objects to, well, or from one database to another during migration. All right, so anybody have any questions about that? So anybody have any questions about this? Okay, so when we get to relational databases, so SQL Server, you all pull a picture in your mind of a table, right? A table does not look like an object class at all. It doesn't at all. You should all be agreeing with me, because you're like, no, it doesn't. If we go back to slide 4, you see at the bottom, relational databases have tables. Objects store objects. And so we see this difference right here in the bottom of this picture. Object-oriented model, relational model. Object-oriented models have classes, right? Relational models have tables and tuples, right? Rows of data representing them. All right. So what occurs very quickly is whenever we have this type of transformation between objects, so when the application's data layer has to interpret the underlying data system's constructs, right, to create the objects for use within an object-oriented application, we have what's called an object-oriented mapping impedance mismatch, right? This is a common definition that tells application people that our underlying database doesn't match exactly the definitions of the object used within the application. All right, so everybody's nodding their heads, I hope, and they've had enough of this. The point of this whole slide is when we get to migration, you absolutely must understand these types of things because the application is so dependent on the databases, data constructs, tables, objects, object graphs, however they are, that's what applications are dependent upon. Also, this type of mismatch is not necessarily related to just relational to object databases. Most people know that, or they think they know that. But in its design, it's the fact that the underlying data source definition, right, does not match the expected or designed application's data layer. So if I even have some NoSQL database that has objects in it, right, and the application is still required to transition or transform those objects and their graphs to another shape, it's still a mismatch. So keep that in mind, because when these mismatches occur, that's when migrations of databases get really troublesome. All right, so let's take a look at that, and that's enough talking for everybody. And what I have here is simply a Node.js application attached to my local Mongo database. And let's take a look at those two. So what we have here is a Mongo database that's we'll start and connect to. And this is a Mongo database running on Windows. And first of all, when you see this, so here's the install of Mongo database. I'm going to start it and run it. So MongoD write, and we're going to bind all the IPs. And within Azure, what this does, it allows my public and my private IPs to connect to the instance of the Mongo database running. And so there we go. And this one's running just in a window. And what we have here is what's called Mongo Compass, and I'll be covering these tools. But once we get into a Windows environment and we install the Mongo database, and then we've got client tools that we can use, we really want to use them because they make the understanding of the data itself. As you can see, I have a simple collection here in my Mongo database that's giving me things to do like mow the lawn. So this one is also connected to currently to the Linux server, which is on my private IP in Azure on 2.9. What we want to do is connect to our current one on the Windows system, which is 2.10, and this is going to set up a minute. What I'm going to do while it's doing that is what I'm going to show you is my Linux system running, and we're going to load up the Mongo server there. I hope it's still on that IP, and we're going to open that guy. It is, and so we're going to log into the Linux server. On this one, the Mongo database is running as a service, so I didn't have to start it. And what we would do there is just simply look at the Mongo client, start the Mongo client, which starting, and then we can give it a command like what database is the default database. So in this one, it's test database. I hope you all laugh a little, because while I think command line is awesome and it makes me a really cool geek, I also is really hard to understand. So what I like to do is I like to say, hey, why don't I just use the GUI client to look at the data in there? And in fact, that's a lot easier for me. So now you can understand that here's our Linux server. Here's the Mongo database. Here's the here's the Compass client used to connect to that thing on that IP address, which is listening. So we have an understanding of the environments. And then this is the Windows server running another instance of Mongo database. Okay, so we got all that covered, and you guys can see it. And so what we're connecting to is 2.9. That's the Mongo database. And this is an application. It's a Node.js application. It's a demo one. We can get it. Here's the sample. It's the MongoDB samples from Microsoft. And as we can see in here,
But before that, if you show the object, it's reside in that MongoDB, the database, it will be helpful.
Yeah, sure. So, and thank you, by the way. And so this one's families, right? That this application creates and edits. And for the demo, what I'll do is I'll throw it away. Because I guess I could have been prepared here to have that going. So we drop the database. And now as we watch it, the transition that's going to occur in this particular demo is we're going to connect to the database. We're going to create the families, insert the document into Mongo database. And you can see the test application actually wants to remove the document, and I just commented that out. So we're going to run that, and the demo gods be willing, it will execute. All right, so it seems it did run, and we can go over and take a look at the Linux server. So I'm the Linux server database that I'm using the Compass client to look at. And so we need to actually refresh this guy, right? So we'll just go here and we'll connect. I found that the Compass client does often refresh what's going on the servers, and we get used to how kind of the SQL Server Management Studio runs, and so this is just a simple client, runs pretty well. Okay, and what we see is that it ran, it connected, and it created the families database, and it created my record and it inserted it. Okay, so as we look at what might happen with a transition to the Cosmos database, the first thing we would have to say is there any disruption in the types of activities that occur within the API? And the way we might take a look at that is we would just simply go up here and we would modify the connection string. And the idea behind this is really a greenfield approach, right? Is that I have an application using Mongo, right? And now I want to use Cosmos. And so what is required? And what is required simply is changing the connection string. And so the MongoDB connection string that we have here is available very straightforwardly when we go to our Cosmos database that has the Mongo API. And I want you guys to see something that I learned as I went. And you see my two Cosmos databases here. So one, I actually put the API type on it. The other, I didn't. It's an SQL API. I find this really helps when you label the names of which API is supporting when you're testing them, because you forget. So now we're within the Mongo API Cosmos database, and we can look at what I've done before in here. And you can see I created the families and family database as a test beforehand, and we can see that it had the same one. But let's just do it again, right? Because it's for you guys to see families database, right? That it connects. And so what we really want to do in this demo is talk about the connection string, which would be the Mongo API connection string within Cosmos database. And you can see it's right here. Primary connection string. And let's jump back and take a look at our, I'm going to paste it right below here and then tab it in. I mean, you guys know you don't want to anger the demo gods too much, right? I line it up like that, you can see, yeah, it is the exact correct connection string that I have, and I pulled it. It's exactly the same. So to complete the demo, really, we just want to run this guy again and say, hey, Matt, if it really is, a simple transition using the API types, then it should just go and create the families database in there. Right. In fact, it does. The reason for this demo is to really remove a lot of those barriers for understanding about what API and the API layer does, right? We have to understand the underlying data types, but the API represents how the applications talk to the Cosmos database. That's kind of that underlying reason for why we talk about it being multi-model, right? Is it supports the models and it supports various types of APIs. I have here Node.js running in Visual Studio connected to, this is a Linux machine running Mongo, and then I can just change the API and run it in Cosmos. So I hope that kind of, you guys are saying, oh, okay, I'm starting to see how this all fits together. So question in there really quickly.
Much to understand the actual intention is earlier you had family DB in on-premise server, so you create a similar database in Azure Cosmos DB from your code. So only changes only the connection string you modified. That's I understand is correct.
It is correct. Yeah. So okay. And that is correct. And the important part there is it's greenfield. Right, is that there was no migration, so to speak. What I have is the application that is using Mongo, and then I just flip the connection string after creation of the Cosmos database with the Mongo API, and now the application's using Cosmos database API. Everybody see that?
Yeah.
Good. So because we start simple and then we get tough. So we're gonna ask. So I always believe that when we do database migration, it's in the context of the application. Always in the context of the application consumer. So we have to understand: is our purpose of migration only to rehost the data? Our example was greenfield, right? So maybe we just want to restart the application in a new area. That's kind of the first question. Second question is it an object relational model to an object relational model migration, right? Is it Mongo database to Cosmos database? That's OR to OR and is linear and very straightforward. If it's not, then we're going to ask ourselves, is some type of transformation required? So luckily, we're going to go talk about all those things and demo them right now, and maybe I can break a demo or two. Everybody excited about that? Okay, nobody's excited.
But not like. sorry, just a minute. But behind the screen, how really it's taking the request, because if it's on-premise, so we know that this MongoDB corresponding provider will invoke, and accordingly it will interact with the database from the application.
Yeah, correct? Yeah, that's exactly right.
So from Azure Cosmos DB, how internally it's working and how it's identifying this is a database. Here we are connecting, and from where we are fetching. So I'll try to understand the behind the screen mechanism.
Okay, well, I think what you're asking about is the connection strings, right, that are used with the APIs. And so we're going to actually do a couple of the APIs connection strings right now. And that's why we transitioned to tools and assistance and guides, a couple links, and you guys will get this PowerPoint. And this gets a good start for us. And what I like to do is, so in this particular one, I have the Windows machine. This is the Windows VM. Hey, I'm getting a phone call. This is the Windows VM that's running an instance of Mongo database for Windows. That's entirely okay. I mean, you don't have to run Mongo database on Linux, excuse me. And then you saw that I have the Linux one running as well. And the way to tell that is by my IP addresses here. That 2.9 is the Linux Mongo, and 2.10 is the Windows Mongo system. So I also like to run SQL Server Management Studio as a tool if I'm planning to show you guys how to do a relational to object relational migration. And if you just said, oh, that's SQL Server to Cosmos database, you're correct. So here I've got my SQL Management Server up and running. There's a tool, this is an important tool to understand, and this is called the Document Database Migration Tool. It's referenced in the documents, and you guys can find it. And what we need to see just briefly right now is the Document Database Migration Tool supports many types of migration methods between, as you can see, linear and nonlinear types. So we really are talking about relational to NoSQL. Right? We have Azure table support, JSON, CSV files. So this is the AWS DynamoDB, which is, I don't want to irritate our Microsoft friends, but the competitor to Cosmos database. Other types of databases. So here's where we start. I guess the issue with this particular tool is it's open source. So although Microsoft refers to it in their documentation, they don't support issues with it. And there are a number of issues. The primary being that it doesn't support MongoDB migration to Cosmos database. It kind of seems like a big one. So it does work very well for export and import of JSON files and those types of things. And let's go do one of those right now, and then we'll come back to this guy. Other tools. As we can see, let's flip back over to Visual Studio. And we've got this guy running. This is my Node.js application. I have another one running in Visual Studio here. And this is the demo from another one of the demos on the Microsoft site. This one is the .NET application using the Cosmos Database SQL API. And so the question was, hey, let's take a look at those connection string information that we'll use. And I want to show you that in the web.config file, right here is the connection information for so for both of them I have running, but the one I'm using right now in this application, so when I say both of them, I have both the Linux Mongo API, you can see that loaded here. But currently I'm using the SQL API and its connection. And so when I attach to the Cosmos database with the SQL API, right, the tools that I might want to use as I'm looking at that is something called in Visual Studio is something called Connected Services. And if you can right click on Connected Services, you can right click on the project to open the Cosmos Database Explorer that you see here. And the Cosmos Database Explorer is this thing that you see at the bottom of the screen in Visual Studio, and I have my opportunity to connect to either of my current running database types. So Connected Services and the Cosmos Database Explorer. Well, now I have two of them running. That's fantastic. And you can see it's just kind of the web page that represents the databases that are running in. Let's see. I don't think I had anything in Mongo Mat. Maybe in tasks. And we can load up. And so this is really helpful in applications, especially in our data layer, because we can start to see the shapes of the objects that are represented, and being able to view I'm saying shape, but really it's the object graph for consumption within the application's data layer allows us to understand it, and probably that understanding is transitioned best in .NET when we use Link, right? So if we're using Link with the underlying SQL server data provider, right? Link then transitions those query types to the SQL API in Cosmos database. And if you understand everything I just said, then you understand it just works, right? Because then it will pull the objects back into the data layer as defined. Okay, So very quickly, we're going to just run this guy so you can see it. And then we'll get to the migration. So this is the demo that's talking to the SQL API. And all it does is just pick out what's currently in there, and it's a simple to-do list, right? I didn't create this one. Like the Node.js one I created, this one I just picked off, and it's a demo. And when we look in the Cosmos database, let's see, we go back here, and we're looking at the SQL API implementation, and we go down to Data Explorer, right? You can see that I have actually the to-do list database. A to-do list has collections, and then there is the collection type that represents the to-do list. So do dishes is the one. And if you're smart, you might say that that is a different set than the one I got in my application. It looks like I'm running two of them. Sometimes you notice things when you do demos that you maybe didn't make sense. So here's the wash car. All right. So those are the tools. There's one other tool that's really quite important that I missed, and that's why we have this, is we want to go over when you install, let's start that again. So when you install MongoDB, for example, and this is a tool for MongoDB migration, you have your default directory, which is MongoDB, which installs the tools. Here I'm running version 3.6. And here's my bin. I want you to see this, and this is why I brought this one up specifically, is the bin dumps a number of different things in there, right? So we get clients, we get Mongoose, here's the Mongo client, here's the Mongo database that's going to run. But we also get these other tools. We get Bison dump, right? We get Mongo dump, Mongo export, Mongo files, Mongo import, Mongo restore, as well as other ones. What we're interested in is Mongo import and Mongo restore. Right, so these are the primary tool we're going to use to migrate from, in this case, Mongo to Cosmos database. All right, let's get back, make sure we're keeping on target. All right. Yeah. Okay. So we talked about the document database migration tool. And it has many different types of data. We talked about the tools in there, so Mongo import tool. And so what we're going to do right now is we're going to run that demo of migration using Mongo import. And luckily for me, we're going to just talk about it, but yeah, sorry. Okay, let's kind of clean this up a little bit. And what we want to do is go here because we're going to run this in the command line. And lucky for me, right, I have it thought out ahead of time. So if you see this one that says Mongo import, and I'm executing Mongo import.exe, all I want you to show you with is, although I'm going to copy and paste this line, this is specifically the information to connect to the current instance of Cosmos database running the Mongo API. So it's Matt's Linux Mongo API documents. It's a URL string, right? So here's my key, right? So here is the collection it's going to connect to, right? And here is the export file that I have. All right, so how do we get there, right? There's an export file. I want to export out of Mongo. I want to put it into Cosmos. So one of the easy ways to do this is to connect to our Compass. And here's Mongo Linux, and it has Molon. And you know, when you start to do lots of demos, you forget which one you ran before, and you're like, oh man, I wonder if this will break. So I think I ran so this one, test collection, but I'm unsure. So let's just go see if it works, because what's important here is what we want to do is we want to show you how to export the collection from Mongo database and import it into Cosmos. So here, when I use the client tool, right, I'm using a select everything. I do want to export the full collection. I do want it to be JSON in this case, and this is the one I know works, but we're just going to write over that and test it out. So you can see I'm dumping it into the path that's what's in my mongo import.exe command line argument. Everybody see that? It's just very straightforward. That's the first step. And so the size doesn't matter here particularly. It's how we do it. So now I have that available to me in my documents here that was just written. So now let's step back into our command line, and as we're looking at we can see that it's looking at that file. It has the key here and the URL, and so we'll just copy that guy and we'll paste it in there, and it imported 3 documents, so it was succeeded. And so now we want to cruise on over here to the correct Mongo API, right? Linux. And we're going to go look at the Data Explorer. And that was test collection documents. I hope there's 3 in there. There are. And then we can see that the ones that we exported were the tasks: walk cats, walk dogs, and drive car. Flipping back over to our Mongo server and looking at the client tool that we used under Mongo cat, we see walk dogs, walk cat, drive car. So that's, it's a very straightforward type of migration when we do it object to object with no transformation of the object. Let's bring up the tool over here very quickly, because what we want to take is to make sure that we understand that the database migration tool can also be used to export, right, data. And there are a number of questions over when you have large amounts of data and those types of things. For the most part, Mongo import can be used, and then there's a number of questions about how many parallel the amount of parallelism for insertion, right, of large amounts of data for Cosmos database. I don't think I can address those, to be quite frank, because it's a lot of detail. But if we're just looking to use the data migration tool as a different way to export that tool, really what we want to do here is say, hey, let's Mongo export data to a JSON file. Right, it's Mongo database connection. And lucky me, this is just a standard database, right? So here's the database. This is 2.9, which is my Linux system. 2.10 is my Windows system running Mongo, excuse me. And so let's just cruise over there, stick in that connection string, and then verify it connects. Yeah. And so now I'm connected to my Linux system on my local database, which has Mongo Mat, right? And has these. So let's say I want to export that. And what we need here is a couple things in understanding how Mongo query syntax works. So the query syntax for everything is just that. And I don't want to go into all the different query syntaxes there. And then the projection is what, and this is very important, it's what shape do I want it to be when it ends up in its destination. So now we're kind of getting into the fact that shapes change. So that's called a projection. And honestly, I can't remember the shape of it. So let me just look at the shape. Okay, so the shape is ID and task. The default object graph is ID and task. The shape that I want it to be is the same. So that's underscore ID true, comma, and task task. All right. So this idea of shaping objects from target to destination is called projection when we talk about the Mongo database and the Mongo API query language. So here would be the target, and actually I just want to go JSON file. I just want to go local. I did this before. I called it delete me. And then, yes, I do. And it has a couple other questions you can do here, but the ultimate answer is output it. And it did it. And it gave me 0 for transferred. So we can come back and fix that some other time. But the result is usually that you get 3 records in there. And it's the same type of output of what it does is it takes the Mongo collection and outputs it as a JSON file, right? And then that JSON file can then be imported directly into Cosmos with MongoImport.exe. Any questions about that? I hope I showed it all in a very straightforward way. The fundamental is that you take the Mongo collection, output it as a JSON file, and then use Mongo import to import the JSON file as a collection with the Mongo API. No questions? Everybody sleep? I lost a few people.
No. Matt, understanding is earlier you take the on-premise data through command line, you export the data to Cosmos DB, which is residing in Azure. The second is through tool you are importing the data. Correct?
That's right. That's correct.
Okay.
So when we really talk about Mongo, right, database as an object relational database, remember at the top, there are a number of different object relational databases and document databases. And so databases that are object relational models that fit the model of Cosmos database that export very straightforwardly in a linear fashion. The one I demoed was Mongo database because it's very common and customers ask about it a lot. But certainly I want you to understand that the model-to-model migration is the easiest, right? Our next step is back to our slide deck is, okay, we've talked about JSON files. We've used the tools to export, right, JSON files for a very linear object translation between the database types, right? So here we did with JSON, we used Mongo import. There's the example of using Mongo import, and the point of this one I'd like to bring up very quickly for out here is the projection, right? So the projection determines the output shape, right, to the JSON file. All right. So the next thing we're going to talk about here is we just talked about that projection in the Mongo database query syntax, right? That determines the shape of the output. So when we talk about the object relation to object relational database migration, it's not as important because we already understand the consumption shapes by the application. When we move to relational to object relational database translation, then we have a lot more problems. And so these are represented on this screen because as you can see, right, our first kind of thing we really have to think about is this, right, is a relational database is a table, right? Here is the person table, and it's a row. That's not an object at all. It's a, column-based row of data, and that's how the application expects it to be. What happens with the SQL API in Mongo database is it translates, right, that object, that application layer's query syntax to Cosmos database in an understandable way so that the object can be queried. Yeah. So what does that mean, right? What does it look like? Let's look at it because it's hard to use those words to describe it. So here, and we're going to move very quickly back to the SQL API. And so this is my Cosmos database running the SQL API. We're going to look at the Data Explorer, right? And we're going to say, okay, so what's going on in here, right? And so here is the SQL collection I created previously. And it has documents in it, and they are people, persons, right? So what we see over here in the object graph, right, is the person. And if you notice, this is a very flat graph. There are no children classes attached, right? It is as close as it can be an exact representation of the table in the database. I really hope you kind of see that, because if I superimpose them like this onto my screen, when you migrate a database from relational to object relational, a row becomes, right, an object. So if we have no shaping, right, as flat, then it works perfectly. You can, and this is why I'm so cautious in this, is if you do nothing, it actually moves over pretty quickly, right? And the Mongo SQL API does do the query syntax correctly to query the Cosmos database. But if you get, curious at all, you run into tons of trouble. So let's do this migration so we can understand it. The first thing we're going to do is, so I'm back on my Windows system, and we're going to run this guy. This is the data migration tool, and we're going to select SQL Server, and our connection string is over here. So this is the SQL Server connection string, and not the SQL API. So I believe the name is SQL app. Sorry. Probably that's it right there. I hope you all laugh, because it's very funny when you start working through all these things. Forget which is which and what's going on. There's my connection string. Okay, so now I'm connected to my SQL server. Select star from person. So first of all, I don't want to talk about the nesting separator down here. We'll get to that in a minute. The first thing you should see in this data migration between the databases, when we're going to relational to NoSQL, is that I've selected not to shape my object transformation at all. This is just a flat select of the table and column row sets as they are, and to dump them in there, Cosmos database. So now you have a couple choices here, but whereas this didn't work with Mongo database, it works with SQL Server, which is kind of funny, but can cause a little bit of confusion, I think, what I'm trying to politely say. And so our connection string for our SQL guy is here. And you'll see that the connection string is there, but I want to point out one small difference in that guy for you so that we understand it very well. So you see I've got it printed here. Notice at the end that the connection string of the tool requires that you add one more parameter, which is the database. And so what we'll do is, since it has it in there, we'll just go into here. We'll just go into here, and then we'll delete that guy out. Migration tests, this one, SQL mat.
Hey, Matthew.
Yeah.
It's Jeannie Lachlan. I know that we're coming to the top of the hour here, that we may start losing people. But I just want to really appreciate you putting this together. And, that's from me and the entire Azure team, Reef, Harmon, Tim, and know that we're backing you up any way we can help with things.
Yeah, sure. Thanks, Jeannie. I think that really I just have to get through this last migration and show a couple things, and we'll be done. It is the top of the hour. Someone was going to yell at me about talking too much, but it's a really complex topic.
You didn't talk too much. It just I know that at the top of the hour we sometimes lose people.
Yeah.
Okay, thanks.
Okay. So what that means is it's time to start wrapping it up, and we just have really 2 more demos to work through, and we'll be good to go. So here's our SQL API for Cosmos that we were just talking about. What we want to do is make sure we have the database parameter on into that, and then we verify.
Matt, here one question. Why we need to use SQL API? Anyway, you are going to take that SQL relation database data as a JSON. Okay, it will go as a JSON, and it will be like a document kind of stuff. So then why I need to use the native SQL here after while taking to Cosmos?
Yeah. So why use the SQL API? Correct? That's the question?
Because if we take the same SQL from here to there means whatever you are mentioning is correct. But anyway, you are going to convert that shape, correct?
Yeah. So I'm going to fire this off while I answer that question.
Okay.
And so it's going to start running. And the reason is, and you can see I'm translating the entire person table with no shaping into Cosmos database. And the reason why you select the SQL API is because, and I'm going to say this, I think it's right, is 100% of the time the applications using the SQL database in SQL Server are using the SQL syntax. That's the exact answer, I believe, right? SQL Server is dictating the SQL syntax. And so when we go to the Cosmos database, we wouldn't jump to a Mongo API syntax because the application's consumption only uses the SQL syntax.
Okay, I got it. Because I got it. The inline is like the JSON if you have null or some kind of empty. So in application, if they use select is null kind of stuff, that yet SQL API will identify accordingly. It will throw the result. If you go with MongoDB API, it will throw error. Correct. Yeah, I got it.
Yeah, that's exactly right. And it's kind of about, in the beginning, I took so much time to talk about the application's context, right? So if I'm going to use the Mongo API, the Mongo database within a Node.js application, I'm going to be using the Mongo database query syntax, right? That query syntax almost predetermines that I'm going to be moving into the Mongo API in Cosmos database because I will use the same syntax. Everybody should be going, oh, I get it. Is everybody saying, oh, I get it? You guys are all quiet. All right, so let's go take a look at our SQL migration there, since that made everybody laugh. And I can't remember what I just called that column name that I imported. Demo Mata. There it is. So what I want you guys to really look at, this is so important, is that was a non-transformational change in the data from relational to NoSQL object graph. And you're looking at it right here, right? Is that is a flat object graph. There's no children, right? And I hope you guys can see that because the next part is very straightforward. Because what happens is customers, all of a sudden they start talking about these involved things about how they want to go into the Cosmos database or any NoSQL database from a relational database. And what happens is we really have to consider what occurs when we go into object transformation. And it is a pain. So our first demo is exactly that one where we did this. So a couple of things occur when we move out of just a non-transformational migration into transformational, right? And so the first thing that occurs is that, as we saw it denormalizes it and creates flat objects. So if you look at my query syntax here, I have a join between two tables, right? So a join in two tables flattens, right, the result set into one table. When we denormalize as a result of shaping, when we do a data migration, we get a flat object, right? There are no children in it. The next part of that really interests people when they talk about it is that they want to use object-oriented, or they want to match the object graph within the database, so the document the NoSQL database, in this case Cosmos, to the application's consumption. And so that's the data layer understanding of the object graph. And you can see that it's represented on the right is now I have a detailed object graph. In this case, it's a person, right, that has subtypes, right, address and location. And it's when we look at this, you should all see that, oh, that's a class, right? I see it. It's the object class. He's got it. This is a complex object type. And guess what? That's exactly what it is, a complex type. So now we have this idea that we can transition between a relational database, and we can end up with a complex type representing it. So they call this nested types to represent, like in a domain model of an application, exactly what the application consumes. You're probably saying, yeah, okay, that makes sense. That looks like this. And you see this in the transform. And we're almost done, but this is the complex part that you have to build up to. Okay. And I am going to let you guys go after this one because you will have seen enough. And we just need our database connection string. Oddly enough, understanding all of this is what makes us great to talk to about customers. It's not that it's a long conversation, but if you understand all the pieces, you can at least talk to the customer about it. So what you should be seeing on my screen is that I've done two things. One, I've put together an SQL statement that selects different tables, right? And you see that I'm just, putting them together. Second thing is I'm using this thing called a nesting operator, and that's the dot, right? And what the dot does is it tells me how to nest the classes to create or shape the object type that will be stored in the target system, right? So by the way, it calls it subdocuments, but the same words apply in that I'm going to shape that to represent my child classes, right? Or the subtypes within the object class. Does everybody see that? That's all I really have to show you here. I don't need to talk about longer, but so now I'm just going to walk forward into putting it into the SQL API, which is this account. And at this point, it becomes easy because once I understand the shape that I want it to be, it can be any shape. No laughs there either, but that's okay. And then I can run it. So I hope what you saw in this, running through this, and I am out of time, is that there's a lot that occurs when we talk about how to use a multi-model database. Whether it's about, the different types of models that are supported into the database, the different APIs, how the APIs connect to the application itself. There's just a lot of questions that need to be talked about with the customer. Sometimes it can be very easy, right? So if it's just Mongo database to Cosmos database, that's easy. All right, I showed you guys how to do that. It's very straightforward. But if it's any other type of conversation, then we really have to stop and just say, okay, well, what the heck's going to happen when we do this because your application is no longer going to consume your data. Okay, so closing up very quickly. One of the things that's important to talk to customers about is Azure charged by collection. And so while it's very hard to get an estimate about what's going to happen, what you really need to just start out with is that at a minimum, it's about $25 a month, and it's per collection, right? And that's what the minimum amount of RUs, which would be, I believe for the SQL API, that's 400. But I do think it changes just a little. But for the most part, $25 minimum per collection per month. If you really want to get into the RUs, so the resource units available, I didn't have to question myself. They are all 400 each. The pricing can be seen in both the Browse tab within the Cosmos database, so you can go look at the costs that are running per collection. You can also click on Scale and Settings within the collection itself and see the pricing. Right? We talked about my dev box, right? And installing Mongo Compass, which is the client tool for access of your Mongo databases on your dev box, is a great idea, right? We talked about the connected services, right, to connect to the Cosmos database and run the Data Explorer. And there's the Data Explorer running. We certainly walk through the Node.js application for Mongo and just changing the connection strings in a kind of linear model using the Mongo API and Cosmos database just works, very straightforward. We went and looked at, as we were working through our demos, where to find the connection string. The only difference that you might see in here is with an SQL API Cosmos database, they call them keys. And then in the Mongo API, they call them connection strings. So that's kind of interesting, but just look for it down there. Here's the API, the SQL API connection strings for .NET, and this is under keys, as you can see. That's kind of, like I said, interesting. There's a couple of items into metrics and alerts and diagnostics that we will finish up on. And so I have my SQL API loaded here. I'm just going to draw your attention down to monitoring. It's a very important feature. So your metrics are what's going to tell you about what consistency model you're running, what your storage is, what your availability numbers are. Remember, consistency models in Cosmos database is a choice. So that's with an atomic consistency to eventual consistency. That's really not part about what this conversation is in migrating, but certainly you have to know about those choices. When we talk about diagnostic logs, what we're really talking about is the SLAs and how long it's taking to produce results. And so you can see I've set up mine already, and I am connected to my OMS workspace, which should give you guys the idea that, yeah, it is connected to the OMS workspace. And then you can see the types of things that I'm collecting, right? Here's my OMS workplace set up, which we do. Certainly, I don't think we support Cosmos database in managed services. At which time that would happen, then certainly we would connect it up to the OMS workspace there and start collecting the events therein. Okay, moving just over to alerts. Very simple as well. It's very standardized in Azure, what we think. Here is the, an alert that I set up previously. Add alerts are very straightforward. And really what we're interested in here is all the alert metric types, which we're collecting with the metrics. And I think the thing about Cosmos is it guarantees a super high SLA, right? And it is a little more expensive, and it can be a lot more expensive. But I think what we're really interested in is the number of failed request counts. So that might be something that interests me. The other thing was, what happens in the number of HTTP 400 counts. Also, something happened that caused the service not to respond correctly. So those are things that interest me. Okay, so we walked through diagnostics, we walked through alerting, we walked through, so with failover, this is an exceptional point, is that you have an option. Sorry guys, talking a lot. with failover, yeah. So let's go to our database very quickly. We're going to move on down here, and so you see the replicate data globally. So if you remember when I created this service, I unchecked to global replicate the data. Once you check it or set up for replication, and you can see here, add regions. Within this one, I have replication set up already to East US2, and you can see that at that point you can configure manual failover, right, or automatic failover. If you choose to automatic replicate, right, then you're not really going to need to choose the failover option, and you can maybe just turn on automatic failover. And that's kind of the awesome part about being a PaaS managed services. A lot of this is so much easier than it was in the past. And then backups. So I put a lot of documentation in backups here because it's not the way you think about it before at all. In fact, within Azure, you don't have access to backing up the system. It just doesn't work that way. I don't know why. I think Microsoft could easily make it so that it's understandable that if we just hit a button and say backup, it backs it up to wherever we want. That would be easy, but that's not how it works at all. And you need to contact Microsoft support. As a result, there's a number of other ways to do it because nobody wants to wait for hours to retrieve a backup set of their data. And so there's a couple different ways to do this. And of course, Mongo dump and Mongo restore is a favored one right here if you're using Mongo. If you're using some other type of API, so Gremlin or Table or SQL API, the Azure Data Factory has a copy data tool, right, that you can set up and create your own instance backups. So those are kind of the recommended types. I put some links in there for you guys to follow up. Certainly read the documentation from Microsoft about what backup and restore is, so at least we can understand it. Okay, summary, right? Choose an API that matches the application code base, skill set, or implementation. It's very important. Selecting an inconveniencing API is a mistake. That means you don't want to go from an SQL type application to a Mongo API. That causes a lot of disruption and cost, right? Using a known database has many advantages. So it's not necessarily that you need to, that Cosmos database is the end-all solution for everything. We have to remember that, object relationals databases do not fit many application models. In fact, we really have to understand that, relational databases fit our applications really well because they're specialized for a purpose and they work well and they're easy to understand. There's a really great article, 7 Hard Truths About NoSQL, and it just goes through them line by line. So if you're considering, or your customer's considering a migration to a NoSQL database type, or they want to use a NoSQL database type, certainly they should be knowledgeable before they just select NoSQL database type because it's cool. I hope that all made you laugh because it's cool. Geeks aren't cool. Tips, right? Remember, start with the minimal database type, right? Use the Compass client. Remember, select the correct Cosmos API query, right? And you can go execute them in test, like with the SQL Management Studio. In your dev environment, install the tools to connect the pieces. In the dev environment, Visual Studio, install the Cosmos Data Explorer, right? Test both the data types in migration and the transformation process to ensure that they're consumable by the application. I can't put enough emphasis on that, right? Because if you don't know how that transformation is taking place, it's going to cause a lot of problems and a lot of cost. And then lastly, when you create collections, right, there's a lot of hidden costs as you add replication, failover, when you add data to it. If you start using it a lot, the RUs increase. So, I mean, it can get quickly expensive. Hey, guys, that's it. That's the summary. It took me an hour and 15 minutes to get through it, but I did. Are there any questions?